In this video, we're going to talk about the normal standard distribution. So first we talk about the normal distribution. What is a normal distribution? So if you look at this curve, and it looks like a bell-shaped curve, and this is a probability density function for a continuous variable, and we call this a normal distribution. If we think about in real life, that for example, if I talk about the average height of the people in the whole country, or maybe the weight of um, the birth weights of babies, we found out the curve, the probability density curve, look like a bell-shaped curve like this. So that means, so we know that mu is the mass, the average, the balance point of the probability mass, and so we can see it's in the middle here, and it's kind of like saying the a lot of people. So for example, that if it's the height, average height is say 6.5 feet, and most people will fall, the height will fall between this area from here to here. And if the height is, say, maybe very small, 4 feet, or maybe the height is 9 feet, we will have very less people, so the percentage will be very small. So right here, suppose this the standard deviation is so mu, it's suppose the average height is 6.5, the standard deviation is maybe let's say half feet. So some people will, if we take one standard deviation, so mu, this is the average height 6.5, and standard deviation will be, if it's one half, then it's 0.5, and then we get 6 here, and they get 7 feet here. So it's saying that the area under the curve tells us the probability or percentage. So we say, you can see the area shows here, it's 0.683. That means 68.3% of people will height will fall into this area. So it's this is 6.5 here, this is 6 and 7 here. So that's like saying 68.3% of people's height are between 6 feet and 7 feet. Well, I was just giving a random number, so it may not be true. And then if we do 2 standard deviations, so minus 1 standard deviation, it's 6 and 7. And if we minus 2 standard deviation, because this is 6.5 minus 1, which is 5 here, and add 1 would be 6.5 would be 5.5 and 7.5. So if we do 2 standard deviations, so from here to here, the area under the curve given here it's 0.954. That means 95.4% of people's height are between 5.5 and 7.5. So if my numbers are correct, apparently I just picked random numbers, so my numbers may not be right here. But this gives you an idea what the normal distribution is. So at the beginning, when the statisticians, when they were studying the probability density function of the height or weight or something, a lot of them had this shape. So they thought that maybe everything will follow this model. So they call it normal distribution. And if they have something that does not fit this model, they call it's non-normal. So it's abnormal or something. But actually later we found out there are lots of models, they don't fit this model. But we still follow the name. This is called a normal distribution. And so this is a little bit something. And the mu is the average, and it could be anything. But we're going to focus on the standard normal distribution. So we will, like we did before, standardized variable. We convert any random variable always to a standardized variable. So subtract the mean, divide by the standard deviation. So the shape will still be similar to this, but mu will be the average, the mean of the new variable z will be 0, and the standard deviation will be 1. So like we said before, x is a variable. It can change. Like we learned in algebra class, x can be anything. It's a like variable function, and minus something. So like in here, you can see x is a variable, so it has it can change. So it has a mean, it has a standard deviation. After we convert it to standardized variable z, it's still a function. So it still has a mean and it still has a standard deviation, and we can prove this is omitted here in this class. So we can prove to show that this variable z has mean, average 0, and the standard deviation always equal to 1. So it makes things a lot easier. If we look at x, the average, when we call it mean, the mean is mu, the standard deviation is sigma. But if we convert this x to standardized variable z, the mean of z is always 0. The standard deviation of z is always equal to 1. Okay, so we will focus on standardized variable instead of just any random variable. And we use the notation. If it's a random variable, normal distribution, this is the notation we use. So we use the first letter n, and then the average, mu, the mean, and the standard deviation. So we use this. So whenever you see this, you know this is normal distribution, because we know that for standardized normal distribution, mu will be 0 here and sigma will be 1. So if we put n 0 1, that's for standard normal distribution. And when we have two different means, that you can see the shape still look the same. It's just the center, the mean, is in a different place. And if we have different standard deviation, you can see the height is different, because one standard deviation will be smaller for higher mean, and for smaller standard deviation, for moderate standard deviation, it's going to be like this, and a larger standard deviation will be big. So when the standard deviation changes, the shape will change. You can see it has different height, and this is what we talked about before. So the picture we looked at before is just a normal distribution. It's not standard, and this one here is a standard normal distribution. So you can see the mean is 0, and the one standard deviation is 1, equal to 1. So you go down 1 unit, go up 1 unit, and the area under the curve, that tells us the probability. So 68.3% of something will be within the area of 1 standard deviation of average. Okay, so most people will be either a little bit above almost more than half of the people or something falls into this category. And if we do 2 standard deviation, because this is a standard normal distribution, so 2 standard deviation will be 2 units. So you will have from 0 to 2, 0 to -2, and 95.4% of something will fall into 2 standard deviation of the average, from average. Okay, so this is the normal standard deviation, and the definition has a bell-shaped density with mu equal to 0, standard deviation equal to 1, and this is the notation we use for it. And okay, so how do we calculate? Again, we come back to the question: how do we calculate the normal standard, the probability for normal standard distribution. The area under the curve is, so this area here is on the left side of this number, negative z. It could be z could be anything, say negative 1.5 or negative 2.0, anything. And the area on the curve, so z, if z is smaller than this number on the left side, so z is capital Z. We use capital Z for the variable, random variable, standardized variable, and this little z is a number which will be given. So if z is, what's the probability of z less than this number, negative z? And it's the area under the curve. And or maybe what's the area? How do we find out the area under the curve? If z, capital Z, is bigger than this z. And we will explain this in the next video.